All right, hello everyone. Today we're going to be solving compound inequalities. And like I said, we'll talk about those in just a moment. But if you guys could pause your video, I would love it if you would try to solve and graph the inequality at the top of the page. All right, final answer. You should have had the following first. First of all, you should have had x is less than 1, which is your final answer. And your graph should have looked kind of like this. You should have had an open circle here at 1, and you should have shaded to the left. Now, how you could have done this, it could have happened a couple different ways. I chose, first and foremost, everyone should have distributed that -3. Distributing always happens first. And then it's just a matter of getting all your variable terms on one side and your constant terms on the other. Now, just be careful if you put all of your variable terms on the right side, you would have had to make sure that you would have divided by a negative. And when we divide by a negative, we just have to divide or multiply by a negative. We just have to make sure to remember to flip our sign. Now, that doesn't happen here, so I don't have to worry about it. Now, for today, we're still graphing inequalities, but we're going to be graphing something, obviously, something a little bit different called a compound inequality. Now, what exactly is a compound inequality? A compound inequality is simply just when basically two inequalities are combined, and it's done so using what's called an and or an or that compares them. So I always kind of think of like, if you think of like for this one right here, it always, when you see that and or, and is usually more, or and is a little more specific and kind of implies that both things have to be true. Here, on the other hand, if I know x is less than -5 or x is greater than 0, these two things we simply just go ahead and graph on the same graph. Or problems are kind of nice. Or problems are kind of like in The Lion King where it says everything the light touches, everything the shading touches is something that is considered part of our solution. Or what it means, it basically means whatever answers work, whatever answers that you shade can make one or the other one true. It doesn't have to make both equations true. So what we're going to do is we're just going to graph them kind of side by side. My first one, this one, it says x is less than -5. So I'm going to have an open circle at -5, and I'm going to shade everything that's less than that, which means we're going to shade to the left. Now we're also going to do the same thing. We're just also going to graph x is greater than 0 at the same time on the same graph. So I'm going to have an open circle here at 0, and then we're going to shade everything greater than 0, which means we're going to shade everything to the right. And there is your or. Basically, an or type problem, you never have to do any, I'll say, erasing, which might be the case with an and problem. And I'll explain in just a little bit why and is a little bit more kind of finicky. But when it comes to an or problem, it's anywhere that would end up being shaded. Now, and that usually means there's going to be two regions. Does it always? No, not necessarily, but for the most part, it's just anywhere that the shading touches. So even if it's something like an example 2a, in order to be able to graph this, we just have to make sure that we solve it. So because it's an or problem, it just means that we have kind of those two mini equations to solve. On the left side, I'm going to start by getting this x alone. So I'm going to subtract the 3 to the other side. We're going to be left with 4x is going to be less than 8. And then dividing by 4 to get x alone. Now, quick check. I divided, but it wasn't by a negative number. So my sign is not going to flip. So 4 divided by 4 is just 1. We're left with x. And 8 divided by 4 is 2. So right now I can graph that piece. It says x is less than 2. Since it's not less than or equal to, that just means we're going to have an open circle down here at 2. And we're going to shade everywhere that's less than that, which is everything to the left. And now we're going to do the same thing with my other equation. I'm going to get this x alone. So I'm going to add 4 to both sides. We're going to be left with 3x is going to be greater than 12. And then to finish solving, we're going to divide by 3. We didn't divide by a negative, so I don't have to flip my sign. 12 divided by 3 is going to end up being 4. And there's your other half of your or inequality. Open circle, since I can't be equal to 4. There's no line underneath my symbol. And because I'm greater than, that just tells me I'm going to shade everything to the right. And there is your final solution. Technically, they don't know when I say solve, sometimes it doesn't, if it doesn't say graph, you don't necessarily have to graph. But your final answer would be x is less than 2 or x is greater than 4. So what I want you guys to do right now is move on over to example 2b, and I want you guys to try example 2b on your own right now. All right, answers up. Final answer, you should have had x is less than or equal to 1 or x is greater than 6. So if you look at your graph, just double check that you had a closed circle at 1 and you had an open circle at 6 because of the sign. The signs are different on both of them. In your first equation, it started off as a less than or equal to, so it stays that way. Neither of these equations, you really should have had, you shouldn't have ever had to divide by 0 on either of these. Those pop up, like I said, kind of every now and again, and it's just something you have to remember. But either way, let's move on to the and type inequalities. So and is where things get there. It's a little bit of a different mentality because if I think of something being true, so if I'm saying, for example, like something in life that can't be true in an and inequality, that's kind of like saying you can be in math class and science class at the same time. In which case, that's not a situation that could really happen in real life. Inequalities, if it's an and scenario, it kind of implies that it has to make both of the equations true, which wasn't the case up here. Like, let's say, for example, if we look at the example we just did, if I pick an x value that's in something somewhere in the shaded region. So let's say we pick, I don't know, let's say we pick x equals 0. If you take that and plug that into your equation, look at what happens. You're going to say 0 is less than or equal to 1 or 0 is greater than 6. Now, 0 doesn't make both of these true, but it kind of doesn't have to. If it's an or problem, it's kind of like saying it has to make the first equation true or the second equation true. So if you'll notice, 0 is not greater than 6, but 0 is definitely less than or equal to 1. So because it makes kind of that first equation true, that's why it works for an or problem. If you switch this up and change these words right here and you change this to an and, then it doesn't work because it only makes the first one true, but it doesn't make the second one true. So when it's an and problem, the solution is honestly where the overlapping. It's where the overlapping region is. So a lot of times now, what we're going to do on example 3 is not usually what you have to do on any given example, but I like to do it just to kind of show you guys where we're getting our final answer from. So what we're going to do is this first line, we're just going to graph x is less than 5. So that piece shouldn't be too hard. I'm going to have an open circle at 5. And because I'm less than, I'm pretty much going to shade everywhere to the left. For my other equation, here where I'll graph it on the second one, x is greater than or equal to 0. Well, greater than or equal to 0, I'm going to have a closed circle at 0. And then greater than 0 is everything that's going to be to the right. Now, for our final answer, that's what we're going to do on really the bottom one. Now, the bottom one is really typically only where, like I said, where the overlapping region is. So I always kind of think like, I always look here, where it's overlapping is where the shaded regions are really more the same than anything else. Now, usually the 2 dots that we have drawn in, again, are kind of, they still act as a fence. So it really, our solution is just going to start where the first one goes. It's going to end where the other one is. And the overlapping region is really just everywhere in between. So now, we don't always do that on 3 separate graphs. So let's say, for example, if you look down at example 4, let's see what this looks like. So first step, just like the or problem, we still start kind of the same way. We have to get both of our equations where x is going to be alone. So the first equation, I'm going to divide both sides by 4 because I want to get x alone. And I'm going to go ahead and switch this around. I like having the variable first. I think it's easier to read. And my second equation, I'm going to start by subtracting 5 over to the other side. We're going to be left with negative 5x is less than or equal to 20. Now here's where Miss Hardy's getting a little suspicious because what number are we dividing by? A negative. As soon as you see you're going to have to divide by a negative number, that tells me that's where the sign is going to have to flip. Instead of being a less than or equal to sign, we're going to change it up and it's going to become a greater than or equal to sign. So there are like warning bells. It's kind of something where you just have to realize whenever you're multiplying or dividing, you just kind of have to be aware that the sign's going to have to flip if it's a negative. So the division part still handles like normal. Negative 5 divided by negative 5 leaves me with x. 20 divided by negative 5 is going to leave me with a negative 4. And now I can go ahead and graph. So usually I start by kind of putting the boundary points on. So I know for a fact that x is less than 3. So I'm going to have an open circle at 3. And this tells me that I would shade everywhere to the left. Oh my gosh. X is less than 3. Yes, okay, we're okay. Now, on my next one, this says x is greater than or equal to negative 4. So usually what I'll do for and problems is I just won't shade right away. I'll kind of use just like in general, like small arrows to represent where I would shade. And typically for an and problem, you're always going to kind of shade to the region that both arrows are pointing. So since they're pointing to kind of the regions in between those two dots, that lets me know that I'm going to shade everything in between. Now, is it always in between? No, not always. Sometimes it is. But what I want you guys, now, before we do so, there's one other way that you could see an and problem. And it's kind of different to this one. This one, if you notice, when we looked at our first initial problems, it just said 12 is greater than 4x and negative 5x plus 5 is less than or equal to 25. So that started as two problems. Whereas this one, you see two inequality signs, but it's all kind of one massive problem. So what we do is we kind of break it up. We look at first equation is going to be whatever kind of involves the up and it has one of the inequalities. So I'm going to bring down negative 19 is less than or equal to 2 plus 7x. And the next one is going to be where from the start, where that first inequality starts to through the second inequality. So, sorry guys, ignore that. But, so I'm going to carry down my 2 plus 7x. I'm going to carry down the less than, carry down the 44. And you're right back where you were on the other problem. Now our goal is to really just solve for x and go ahead and graph. So what I want you guys to do is pause your video and I want you guys to try finishing this example. All right, final answers up. You should have gotten x is greater than or equal to negative 3 and x is less than 6 if you solved your two equations correctly. So for both of those, just be careful again of the dots. At negative 3, you should have had a closed circle because that sign had an equal sign underneath. And the 6, because that one didn't have an equal sign, the little bar underneath, that just lets you know that it's going to be an open circle. So if you guys want, there's a couple of you try nows at the bottom if you want to try one more of each type. But if you're feeling pretty good, you guys can now go ahead and start working on the homework for the day.